I want to record because I forgot to record the other day, so I'm going to record today. So after we have this information, if we're looking for the amplitude is always a positive value. So even though it says -5 here for the A value, remember the negative is really just a reflection, means we're starting by going down instead of up. The amplitude is just 5. So don't let that fool you on an assessment tomorrow, hint, hint, hint. If you see a negative A value, the amplitude has to be a positive number. So it's going to be +5 based on that equation there for number 1. The period, this one's kind of weird because the B value is going to be what in this particular problem? It's a sine of x/2. So what's the B value? We haven't looked at one of those with a fraction yet. The B value is 1/2. So if you see something like over a number, B is 1/2. You could see something like sine of, let's say, 3x/2. Then the B value would be 3/2. That's how we'd want to write it. Okay? So if you ever see a fraction, don't freak out. I was looking at the chapter review today, and it's always annoying to me because when I looked at the chapter review yesterday, I should say, and when I was looking at the chapter review yesterday, and they had fractions on the chapter review, and I was like, we didn't do any fractions in the entire chapter. Like the chapter never had fraction examples, but then in the review, there's like 4 of them. It's like, oh yeah, probably should have taught that. That's my bad. So that's why I'm bringing it up today on review day. It's not a huge change, but it's something we do need to be aware of that it could happen. All right. Anyway, so in this case, the B value is 1/2. So the way we set up the period of the function is where you say 360 divided by 1/2. Do you guys remember what you do if you have a fraction divided by another fraction? How do you get rid of that?
Flip it and multiply.
Yes, you got it. Multiply by the reciprocal. So you'd say 360 times 2/1. So it really becomes 720. So your period is 720 degrees. That's what happens with part B there, okay, when you're dealing with a fraction. So if it was 3/2 instead, you would do times 2 and then divided by 3, all right? And then the last part, the principal axis, in this case, is just the +2. Whoops. So that's what I love about the equations. It's so easy for the equation. You just write it as an equation, d equals 2. Always write the principal axis as an equation. I was looking at old IB exams last night because it's really fun. It's my favorite thing to do on Sunday nights. And they do ask specifically on IB exams, like, state the equation of the principal axis of the curve. So always write it as an equation. All right. Yeah. So that's the idea here for this particular problem. All right. So that's what these first parts look like. Now, what I want you guys to do, go ahead and sketch a graph of the equation. Try it out. You can double check it on Desmos or something, but I want you to use this as your interval. That's why I gave it to you at the beginning. -180 to 540. Use that as your interval, okay? That's how a given interval would look for this type of problem. All right. Are there any questions?
Should the intervals go by 90 degrees?
Oh, you could count by 90s. I counted by 180 because the period was 720. So remember, we always want to take whatever the period is and break it into fourths, right? So when the period was 360, we counted by 90s. If the period 720, we would count by 180s because that's 1/4 of 720. If the period was 90, I would divide 90 by 4, which is 22.5, and that's what I'd count by. Does that make sense? So good question there. Yeah. So yeah, always count by fourths of whatever the period is. Okay. Problems 2 and 2, parts A and B. Write a function to represent each given graph. Okay. So for these functions, starting with example A. Oh, nice! I put the exact same graph on there twice? That's awesome. Nice work, Street. Way to go. Okay, so I had another one that was a really cool graph too, but you know, instead I just put the same one on there twice. So let's cross off part B. There's going to be some good practice on the assignment, so I think it's fine that we only have one problem on here, but I'll have to fix that for next year. To do a graph here, I want to identify the starting point. So I see like there's a starting point, and then I want to identify my 5 key points. I kind of find out where my midline is, or my principal axes, and I go from -2 up to +8 is my maximum. So halfway between 8 and -2, that'll give me the principal axes. So I'll do 8 plus -2 to find my principal axes. Or I might just be able to see it visually, but this is how I can verify it. 8 plus -2 is going to be 6/2, which is 3. And that makes sense. It looks like it's the middle of this graph. So there's the equation of my midline. So whatever this function is, it's going to be stuff plus 3. That's how I find my principal axes. And then once I have that principal axes, I can see I'm going from 3 up to 4, 5, 6, 7, 8. So there's going to be a 5 right here. Okay. That's my amplitude is 5. And again, I could do the max algebraically. I could solve it. Amplitude is max minus the min divided by 2. So in this case, 8 minus -2 is like 8 plus 2. So it just comes out to 5, which is good. That's what I wanted. And then a period of the function. I always like to do a period from peak to peak. So it goes from here to here. And that's going from 90 to 270. So I can say 270 minus 90 equals 180. All right, so that's one period of the function. So period equals 180. Now I need to find the b value. 180 equals 360 over b. So it's like working backwards to find the b value. And now I can rewrite this as 360 divided by 180 equals b. Because you would multiply both sides by b, divide both sides by 180, and you end up getting like a b value of 2. So it's going to be like a 2x in there. That's my b value. And then the last part, determine whether it's a sine or a cosine function, whichever one you want. You could write both technically, but we didn't talk about this year and what your textbook, what the IB exam doesn't really expect from us too much is horizontal shifts. Those ones are the toughest ones. Let's see, why are we not charging here? Sorry, my computer is not charging. Let me get back to charging real quick. There we go. Now my computer's charging. So anyway, what we did not talk about was horizontal shifts. So what we want to do then is we just want to look straight on the y-axis and see, is it starting at a middle or is it starting at a min or a max? And this one's starting at a min, which makes it a cosine function. And because it's starting at a min, it's going to be a negative cosine function. And I'll just highlight that in yellow here. Yellow, and then that point right there. So it's negative because it's starting at a min. It starts at a min value. That's why it's negative. Okay? And it's cosine because it's starting at a min as well. If we're starting in the middle of the graph and going down, it'd be a negative sign. If starting in the middle of the graph going up, that's a positive sign. All right, so that's how you would write a function from a graph. All right. Problem 3 is a very similar style problem to that, where it's going to ask you to write a function for that one. All right, so problem 3 is a great example of where the period is not going to be 360 degrees. It's not in terms of degrees. The period is going to be in terms of the real world situation. I want you guys to go ahead and give problem 3 a try. All right, so give it your best shot. Take a few minutes to read over it and make sense of what's going on in the context of the problem, because you're going to have a problem like this on the assessment tomorrow. So I want you to practice right now with it, and then we can go over it together. Here, hopefully you guys have had enough time to look through it. So it says find the exact values of P, Q, and R, and this is something the IB exam likes to do, is switch up the variables on you so you're used to the A, B, and D, but they switch it up, but it's the same idea, same general concept. The P is just the amplitude of the function, so you don't need to panic. You just need to ask yourself, okay, what's my amplitude going to be? So I'm going to sketch a quick midline here. It's going to be somewhere in the middle. And in order to find the midline, that's like y values here. So the bottom is 0.06, or not 0.06, but 0.6. The top is 1.5. So I can say 1.5 plus 0.6 divided by 2, 2.1 divided by 2, I get 1.05. That's going to be my midline. So that's my R value. Oops. R equals 1.05. And on an IB exam, you will be expected to show some work algebraically, so you'd want to set up this type of equation for it. All right, being able to add the two together and divide by 2. For the amplitude, I would just say P equals 1.5 minus 0.6 divided by 2. And that becomes 0.9 divided by 2, which is 0.45. There's my amplitude. So I know how to find midline and amplitude. And I wrote up here the y values represent the amplitude in the midline. Just as a reminder for myself, the x values represent the period of the function. So if I'm looking at a period of the function here, I can see I start at 0, and the next peak is going to be at 12.5. So that'd be the period. So the period is 12.5 hours. That's your tidal period for tidal waves. Or not tidal waves, but for the tides. So now what I would say is 12.5 equals, where is it? My 360 over B. And then I go ahead and solve for my B value. So I say 360 divided by 12.5 equals B. and then plug that in and get my b value. It's going to be some weird number for this particular problem. $28.8. All right. And now I've got my equation set up. H of t equals 0.45 cosine of 28.8 t plus 1.05. So now I've got my equation set up. And now it says, what is the time when the second high tide occurs? The second high tide on December 3rd, 2020. And the IB exam likes to do questions where, let's say I struggle with part A, I don't know how to do P, Q, and R. I should still be able to solve part B. So make sense of the problem. Hey, high tide. Here's the high tide. So I'm starting at 9 p.m. on December 1st. That's hour 0. And then I'm going 12 and a half hours later. So that means this right here, peak, is 9:30 a.m., 12 and a half hours later on December 2nd, 2020. And that means if I go another 12 and a half hours, this is going to be 10 p.m. on 12. So the second high tide on the 2nd is going to be at 10 p.m. And then we go another 12 and a half hours. So do you guys see how that works? You could do this without any algebra skills at all. And you can just look at the peak and of the waves. So you're just making sense of what the data is actually telling me. So then the next one would be 10:30 a.m. on December 3rd. And then another 12 and a half hours later, it'd be 11 p.m. on December 3rd. So it'd be 11 p.m. would be our second high tide on December 3rd. And again, that's an IB exam thing where they say if you can't do part A, you'd still be able to solve for part B, all right, to figure it out. Okay. And yeah, and what we'd be doing is we'd solve algebraically for t, which we didn't really talk about on these particular problems, right? We would just say you solve for when the height equals 1.5, but that's going to be repeating every 12 and a half hours. So yeah, okay. And I would recommend doing is graphing it to solve it, but the graph's already given to us on this particular problem. All right, so that's how it works. You have to make sense of what the graph is telling us. Okay. And yeah, that's something in this module, or not in this module, but in this chapter that we talked about this year. We weren't asked to solve algebraically for these problems. We were just asked to graph them to solve. And that's what problem 4 is asking us to do. This is the last problem today for class. Use a graph to solve this. So we're going to graph the equation y equals sine of x. And then we're going to graph the equation y equals 0.4. And we're going to solve for this interval 0 to 360 degrees. So when I graph, real quick, I'll sketch a quick graph here for us. Sine of x is going to go like this from 0 to 360. So it goes up to 1, down to -1. It's going to be 90, 180 is going to be the midline, and then over to 360. Not the midline, but 180 is going to be halfway point. That's going to go all the way over to 360 degrees. There we go. Now we're looking for when that equals 0.4. So we should have two solutions that we need to find on our graph. If you're taking the IB exam, do it on your graphing calculator. Make sure you find those two solutions by guessing the left bound or the right bound and then honing in on it. All right, but you graph both lines. On Desmos, it's really easy to look up. All right, so go ahead and practice on Desmos or on your calculator. Find those two values. I don't have it right in front of me. Does anyone have those two values by chance, or find one of those two values? All right, so I found my equations, and I got x equals, looks like the first one was like 23 degrees, 23.578, and the second one was going to be 156.422. So I'll say 23.6 degrees, and then the second one 156 degrees. And that's just because IB exam usually does 3 significant figures. So that's why I'm doing the rounding like that. 3 significant figures just means three numbers. Okay. So x equals 23.6 degrees, x equals 156 degrees. Be able to graph it on your calculator. Look on the left viewing window, the right viewing window. If you need help doing that on your graphing calculator, let me know and we can look through it together. Otherwise, you can use Desmos. That's perfectly fine to do that type of problem. All right, well, that covers everything for today. We're done a little bit early.